Welcome to Circuit 5A, Motor Basics. So in the circuit we have three new components that we will be using. We have a switch, a motor driver, and a gear motor. We will be using the motor driver to control the speed and the direction of the gear motor. Normally we would have to rewire our gear motor anytime we would want to make it go forward or backwards. The motor driver allows us to control the speed and direction of the motor by using this portion over here. So in this area we can control the speed and direction of the motor, and in this area here we are able to direct electricity to motors, and we can actually control two different motors, but for this circuit we will only be controlling one motor and only using pins A01 and pins A02. If you want more details as to what the other pins are for, review this diagram that's provided by SparkFun Electronics. One key feature to note is that usually we power our board with 7 to 15 volts. However, whenever we connect our breadboard to our breadboard, we connect our breadboard to our 5-volt pin. We provide 5 volts of electricity to all the components in our board, but when we do include resistors, that voltage decreases. Whenever we connect an item, for in this case, this motor driver, to pin VIN, we will provide the same amount of electricity as we are using for our power input that is going directly into our breadboard. So for instance, if our power source is supplying 12 volts of electricity, then we will directly supply 12 volts of electricity to our motor driver, and thus our gear motor will also receive 12 volts of electricity, while the entire breadboard will receive 5 volts of electricity. Another new piece of logic to consider is that we are activating this other side of the breadboard at the same time. So if you notice, we have two wires going from this ground section to this ground section over here. We have this entire column for the ground. When we place this wire on this side of the breadboard, we activate the entire column. The same goes for this red wire in these two columns here. Both of these columns are activated. An important factor to consider is that you need to use a serial monitor to control this gear motor. And notice that you do have to enter a motor speed, and once you enter a motor speed, you're going to notice that you do have an option of including a minimum value of 0 or a maximum value of 255. So I'm going to type in 255, I hit enter, and my motor goes fast. And if I flick my switch, I immediately turn off my motor. And then it keeps moving if I flick the switch again. And to turn off the motor, I can put a value of 0. So lines 16 through 18 and 20, we are identifying what pins we are using, and we are assigning a variable to each pin. In motor speed, we always start off with a value of 0, so our motor does not run. In void setup, we are identifying what are our inputs and what are our outputs. We also communicate with our serial monitor, and we provide a message in the serial monitor. In void loop, we run the code over and over again, and we will only be messing with our code with this section here. So do not worry about the other sections, we will only be using this section here. In void spin motor, this is the area where we allow our motor to run in a certain direction. Depending on what value we put in our serial monitor, our motor will either activate a certain pin or it will not activate a certain pin. So this will allow our motor to move forwards or backwards, or to not move at all. Notice low and low, we do not send electricity to our motor driver. In line 40, we only activate all of this code here if we write a value into our serial monitor. So we notice that motor speed will equal whatever value we enter into our serial monitor. And then this is just saying we're always printing motor speed. So once we enter a value from 0 to 255, we can also use negative numbers. Once we enter a value, we will get a message saying motor speed, and then we will also print the value, which is what we see here. We print out motor speed and the value. If we include a value, then we have a motor speed, and in that case we will run that value either positive or negative 0 to 255. And if we don't include a value, then our motor just stays off, and that's pretty much it. So we are only messing with this section here. So in line 47, what's going on here is that our switch is controlling our motor. So if the switch is on, then we will spin our motor with whatever value we put into our serial monitor. If the switch is flicked in the other direction, then our motor will not spin at all and our entire device will not work. For challenge number 1, we are going to make the switch change the directions of the motor. We're getting a little bit laser and we don't want to enter the motor speed into the serial monitor anymore, so we just want to flick the switch and we'll either turn the motor on or off. So let's get rid of motor speed and let's just input a value. So I'm going to put 250. So in this situation my motor is running, so I'm going to turn it off. Notice I did not do anything with the serial monitor. Both of my hands are here. And I flick my switch and my motor runs. If you want your motor to go in reverse immediately, you can just type in -250 and just watch what happens. For challenge number 2, we're just replacing the switch with a button. So we don't actually have to change anything with the code. All we need to do is just take out the switch and place a button in there. So I have my button. I'm going to adjust the wiring. And now whenever I push the button, the motor moves forward. Now we can also do the same for challenge number 3. We replace the switch with a sensor. We're going to specifically use a photoresistor. So since I'm adding a new component, I will disconnect my breadboard to make sure that the circuitry does not get damaged. So I'm taking off the button and placing the photoresistor. So in this case, I need a 2 kilo ohm resistor and my photoresistor and 3 wires. So I already have 2. So let's go ahead and place this here. My 10 kilo ohm resistor, remember, it needs to have a black wire. I did not add the 3rd wire that's in the middle, which would be going to the analog input. I instead placed my finger on top of this photoresistor and it just turns off. So all I did was just add photoresistor with the 10 kilo ohm resistor. And let's actually test to see if this works without the 10 kilo ohm resistor. No, we actually need the 10 kilo ohm resistor to minimize the amount of power going through the photoresistor. Alright, so this is some bonus content. We're going to expand on this circuit here and on challenge 3, and we're going to add some code to control this motor with a photoresistor. We're going to start by saying that our photoresistor reading will always be reading an initial value of 0, and we're going to set our threshold at 750. So let's put this right above the void setup, not in void setup. Then we go to void loop, and let's copy this portion here. So this will actually allow us to read our analog input and assign a value to the term photoresistor. So we're doing that on line 43, right inside void loop. We're also going to get this term here, serial print ln, to just read out the values for the photoresistor reading. So let's put that in line 40. We're not controlling our motor anymore with our switch, so let's go ahead and copy this if statement here. And we're going to get rid of this portion here because pin 7 was associated with the switch. So let's actually paste our previous copy and paste it there. Now let's go ahead and upload it. One word of caution. So keep in mind that you do need to remove the following components. Make sure you get rid of your switch and these 2 wires, just go ahead and remove them. And in place of these items, make sure that you put these components there. 1 photoresistor, a 10 kilo ohm resistor, and 3 wires. Notice how the wires are connected. It is important that you connect it in this manner. So make sure you turn on your serial monitor. And let's see how this is going. So notice I'm currently reading a value of 845 with my photoresistor. That is very bright, so I'm going to decrease the light. It goes down very slightly. And notice if I turn off my light, my photoresistor turns on because my reading is lower than the threshold, which is 750. So experiment with this and good luck.